Today I want to look at absolute value functions, and so I want to start off with an example. In this case I want to graph 3 times the absolute value of x minus 1 plus 2. If you've seen my previous videos, you may recall the function translation formula that we use, where it says that if g of x equals a times f of x minus h plus k, then we know something about the graph of g of x. Remember, a is that coefficient that either broadens or shrinks the graph. It flips it upside down if a is negative. The h is a horizontal translation to the right h units, and the k is a vertical translation. We go up k. So if I know the graph of the absolute value of x, then I can easily take on this problem. Alright, do we know the graph of absolute value of x? Yes, it looks something like this. Just a V shape that meets down at the origin, and that's it. And that makes sense if you think about it. If I plug in positive 1, the absolute value of positive 1 is 1. The absolute value of positive 2 is 2. If the absolute value of negative 1 is positive 1. The absolute value of negative 2 is positive 2. If you keep doing that, you'll generate this nice V shape. Alright, so that means then I know a lot about the graph of the one in question. So I'm going to compare this graph here, my f of x, to this absolute value of x. There's the absolute value of x. Okay, now what does the 3 do? The 3, since its absolute value of that is greater than 1, it's going to condense it. It's going to kind of shrink it up like this. It's going to make the V straighter, okay? Now the negative 1 means that h is 1. So that means I have a positive shift to the right 1 unit. And the plus 2 means I have a vertical shift 2 units. So something like that. Alright, so there's my new origin. So just try my best to copy that same graph right there at the origin. Okay, I'm going to erase this other stuff so we can see it very well. And there it is. There's my graph. Alright, let me show you one more thing about the absolute value graphs. Okay, so here in this example I want to graph f of x, which is the absolute value of x plus 2 quantities squared minus 1. This is a little bit different because it's not the absolute value of x, it's the absolute value of something squared. Alright, so how do we do that? Well, first of all, let's graph this function. I'm going to call g of x. Let's graph x plus 2 quantity squared minus 1. Okay, well, I know something about that graph because that is a parabola in vertex form. So it has a vertex of negative 2, negative 1. So my vertex is down there. A is positive, so it opens up something like this. And really, I'm not too concerned about the intercepts and stuff like that right now because I'm just trying to get a picture of this graph. Alright, so there's g of x. Now, here's how you take f of x. You copy the same graph on the part that's above the x-axis. So that's the same, right? What does absolute value do? It makes everything positive. Okay, now this part that's below the x-axis, you're going to flip it like a mirror image. Like that. And now erase the blue, which was the negative part, and there it is. There's f of x, the absolute value of x plus 2 quantity squared minus 1. So again, if you had a function that did something like this, okay, so here it dips down below several times. Again, what you do is you trace the positive part. That stays the same. The negative part mirror images as best you can above the x-axis. Let me release my blue line. So that would be the absolute value of the original function. I hope this makes sense. If you have any questions on absolute value functions, I'd be glad to help. And thanks for watching.